Flink can be deployed through different resource provider platforms, such as the Flink native standalone resource provider, Kubernetes, or Hadoop yarn. In our course, I will introduce the Flink standalone and the Hadoop yarn. The Kubernetes are beyond our scope. The standalone model is the most bamboo way to deploying Flink. The Flink service described in the deployment overview are just launched as a process on the operating system. Like deploying Flink with the resource provider, such as the Kubernetes or yarn, you have to take care of restarting field processes, or allocation and the allocation of the resources during operations. The Flink standalone resource provider supports two deployment models. First is the session model, and the second is the application model. But the application model not support good under the standalone resource provider. In session model, assumes an already running cluster and uses the resource of that cluster to execute any submitted application. So, in order to deploy the Flink application by session model on the standalone resource provider, we have to start the Flink standalone cluster in advance. So let me start the Flink standalone cluster by start cluster command. Execution that. Wait one moment. Okay, the Flink standalone cluster is started successfully. We can use the GPS command to check that. Node 1 and node 2, node 3. Because we distribute the job manager and the task manager to the node 1, right? The standalone session cluster entry point. This is the job manager OS process name. Okay. And also we can open the browser to check with start and existing the standalone cluster. And available task slots is a 6, and the task managers is a 3. Okay. Let me try to submit a Flink job at here. Use the Flink command. The run option. Detach model. Specifying the job manager. And specifying the class fully name. Entry point class fully name. Okay. And specifying the job parallelism 4. Specifying the archive package. Execution this command. As you can see, our Flink job is submitted successfully and opens the job manager web UI. As you can see, the available task slots is updated to 2. In other words, our application used 4 task slots, right? As I mentioned at early time, the session model has a serious disadvantage. The cluster resources are a fiction. So when the slots of the resource are efficient, the job manager will reject a new job submit. Let me try to submit another job and the parallelism is 4. The submission will be rejected by the job manager. Okay, let me show you. Re-execution this command again. Okay, it looks like we successfully submitted the job again, but actually it's error and rejected by the job manager. As you can see, this job is a field. We can click the Flink stream job And we can click the exceptions table and scroll down. You can see as a cost by, we do not acquire the minimal required resources. In other words, our submission applied 4 task manager or 4 task slots, but in our cluster, it's only available 2 task slots. That is the resource efficient. All right, this is the serious disadvantage of the session model under the standalone cluster or under the standalone resource provider, right?